Okay, in this example, suppose we have a plane and okay, in this example, surface. Okay, this example is referring to the problem of finding biggest circle on a surface. Okay, this example is referring to finding the biggest circle on a surface with some obstacle. So suppose we do have a given surface. For simplicity, we have assumed it's like a square and the dimensions are equal to 1, 1 and 1, okay? 1 and 1. And also there are some points are specified here. We want to find out the location and the radius of the biggest circle that can be placed on the top of this surface without this example is referring to the problem of finding biggest circle on a surface with some obstacles. So suppose we do have some obstacles here on the surface, and the dimension of that surface is 1 and 1. It's like a square, and we want to find out the location and the radius of the biggest circle that we can place on the top of this surface without overlapping any of these obstacles. Okay, so first of all, we want to make sure that every obstacle is outside the circle. Okay, so if the center of the circle is specified by capital X and Y, then xi and xj and yj are all already specified for us. These are the coordinates of the obstacles. And also we want to make sure that x is bigger than r, because we don't want to have a circle outside the surface, and also x is less than 1 minus r, so the circle is not coming out of the box from this side. The same philosophy holds for y. Okay, so let's have a look at the Python code for this purpose. Okay, so first of all, I import every required packages, and also I define the abstract model. Parameter n is telling us how many obstacle we have, and also the range of them is specified here. So we might need a random initialization. Okay, so for this purpose I define this function. So define an init val model and I. For every I can provide you an initial kind of location for those obstacles actually, and also the x, y and r are or variable decision variables. They are positive numbers varying between 0 and 1. Okay, so they are all on this surface. Okay, so we want to find out the area of that circle as the decision variable or the objective one. There are some rules. The first rule is making sure that every obstacle is outside that circle. The other one is telling us that x is bigger than r. I couldn't put r here on the interval because r is a variable, and y is bigger than r as well, and y is less than r, 1 minus r, and x is less than 1 minus r, okay, as we discussed before. And also the area is obtained by this formula using this constraint. So the objective function is obtained using this expression model.area, and the sense is maximization. I choose the solver, okay, I choose the solver. I can specify the number of obstacles here, and finally ask matplotlib to show me the obtained solution. I run the code and see the results. Okay, so we have to wait and see the results here. So 50 random obstacles are generated on the graph here, you can see, and then the center of that circle is found, the radius of that circle is also found. You can see it here. Okay, so you can easily change the number of obstacles. Instead of, let's say, 50, let's try 10. Okay, and rerun the code. So for 10 obstacles, the location of the circle is also found. The radius is obviously bigger than before, and also the location of the center of this circle is updated. Thank you very much.